Today, we will investigate ratios, proportions, and baseball. It's the baseball ratio proportion problem. There are two ratios in particular we will work with, the strikeout to walk ratio and the batting average. Don't worry, it won't be hard. First, we will define a ratio as a quotient that has units. Ratios can be described as A divided by B and the ratio of A to B. The two ratios that we are interested in are strikeouts divided by walks and the number of hits divided by the number of at-bats. Next, we define a proportion as a relationship that says two ratios are equal to each other. Here you see the ratio 3/9 is equal to x over 27, where x is an unknown called a variable. We must solve for x. So this brings us to the pitcher's corner. An MLB pitcher throws 212 innings this past season and collects 199 strikeouts while walking 20 batters. What is his strikeout to walk ratio? The solution isn't all too hard. Remember, the strikeout to walk ratio is the number of strikeouts divided by walks. So we plug in 199 strikeouts and 20 walks and we get 9.95. Is that our answer? No, we need our units. Let's revisit the question with a slight change. The pitcher has 2 games left and wants his strikeout to walk ratio to be 11. How many strikeouts does he need with no walks? For the solution, we now have the strikeouts are unknown, so it is marked with the variable x. X over 20 is equal to 11. Solving the one-step equation and canceling out our units, we get strikeouts are equal to 220. So subtracting 199 from 220, the pitcher needs 21 more strikeouts in 2 games. Into the batter's box. An MLB hitter collects 188 hits during the season, and his batting average is .376. How many plate appearances did he have? For the solution, we remember that batting average is the ratio of hits per at-bats. So then we substitute in 188 hits, and the average is .376, which means we must solve for the number of at-bats. Sometimes it is easier to imagine .376 divided by 1, and now we have a proportion. So, continuing, we have a two-step equation, and now we cross-multiply to get 188 equals .376x. Then we reduce the equation by dividing by .376, and that gives us x equals 500 at-bats. Let's change it up and make it a little bit more interesting. Now, the batter wants to hit 400 before the season ends. How many consecutive hits must he get in each at-bat? The solution, we want a proportion so that the batting average is 400. We let x equal the number of consecutive hits in each at-bat. So we have his old batting ratio with x added to each equal to 400. Then we cross-multiply and thus distribute the 400 onto the 500 plus x to get 200 plus 400x equals 188 plus x. We have a two-step equation. Continuing, we combine like terms to isolate the x. We get 12 equals 0.6x. Division undoes multiplication, so dividing by 0.6 gives us x equal to 20 consecutive hits. Congratulations! Now you know more about baseball and math. The end.
Created using Powtoon.